All right, guys, so last video about Pythagorean theorem, and sorry there's so many, but it's good to see lots of examples if we need them. So this one that I'm going to do with you here is on this page here, and I actually had two of those screwed up. So just make sure you're looking at the right question while I'm doing this one. I totally put it together wrong, and I didn't realize until I started making this video. So I'm going to turn this one sideways. This is on 72, or it's the next, the second and third page in your packet. So just some basic vocabulary when it comes to the Pythagorean theorem. For any right triangle, we know that c squared will equal a squared plus b squared, where a and b are your legs. C is your hypotenuse, the one across from the 90. We can use the Pythagorean theorem to find the missing side of a right triangle. The sides that are labeled A and B, the ones that are being added up together, are always the legs. C, your longest side, the one always across from the 90, is your hypotenuse. It's the one that's by itself. So we got a bunch more that we can do here real quick. These two guys are legs, so I would do 12 squared plus 35 squared equals I don't know squared. That's 144. 35 squared is real big. 1,225. Oop. And then we're going to add those things up for 1369. And then we'll square root it. I wonder if I can square root that. That's too big for me to think about breaking up. Square rootable, 37. Love it. So another thing that we were talking about are how these three numbers here, since they are nice whole numbers, 12, 35, and 37, are a Pythagorean triple, and any multiple of that would also be a Pythagorean triple because it would just be a similar right triangle scaled up by the same amount every time. So like I could do 24, 70, and 74. So like if I scale it all up by 2. So then this one here, again, these are the two legs. Don't know the hypotenuse, so we could do 16 squared plus 12 squared equals I don't know squared. So 256 plus 144. And when I do add them up, oh, look at that. I get 400. Square root of that is 20. Love it. So 12, 16, and 20 is another Pythagorean triple because they're all nice numbers. In fact, I could divide them all by 2, and 6, 8, and 10 would also be, oh my gosh, and if I divide those all by 2, we get that 3, 4, 5. So all of these are the Pythagorean triples, either scaled up or scaled down by whatever amount. On to the next. In this picture here, I have a right triangle. However, I do not know one of the legs. So we're going to have something like 28 squared plus, I don't know, the other leg squared equals 35 squared. And those are real big numbers, so I'm going to ask my handy dandy calculator to do that for me. So 28 squared is 784. 35 squared, 35 squared is 1225. Oh, I just did that up there. I'm so dumb. And then in this case, it's a little bit different than the last ones. Like next we would just add them up. But the thing I'm trying to solve for is over here with this number, so I need to get it alone. So I'll subtract the 784. So b squared equals 441. Ooh, I think that's square rootable. Yeah, 21. So square root both sides, and b is 21. So again, this 21, 28, and 35 is a Pythagorean triple. Ooh, 7 goes into each of those. 3, 4, 5 times. Oh my gosh. Oh. I wish I would have just thought of that first. Oh wow. Like if you kind of know those Pythagorean triples, you can maybe avoid the Pythagorean theorem and just know your third side by kind of memorization. Which actually this is one of those. So 25 and 24 I know is one of the Pythagorean triples that we talked about on page 73. 24 and 25. As long as 25 is on the hypotenuse, if 24 is one of the sides, then that third side is going to have to be 7 because it's a Pythagorean triple. It's a Pythag triple. Now you can do the Pythagorean theorem to figure it out, but I guarantee you it will be 7. On to the next. These are these story problems that is really based on your homework for this weekend in Google Slides, where it's important to sort of see the right triangle and know where to place all your numbers. So in this city, Antiscotia, I don't know, the school is 3 miles west of the post office, and the library is 5 miles north of the school. What is the distance from the post office to the library? So, I mean, I'm thinking of a compass here and never eat soggy waffles because that's gross. But that's important for me to keep in mind because if I'm like at the school and it's 3 miles west of the post office, then like this is 3. And the library is 5 miles north of the school, so back at the school, but the library is up here 5 miles north of that. So like I had to travel in the right directions to get to the places. But if I'm traveling like north and west or north and east, whichever way you're kind of looking at it, you do get a 90-degree angle right there. And so if I traveled directly from the post office to the library and I didn't go this roundabout way, if I wanted to walk straight there, sometimes they call that a bird's eye view or as the crow flies. I know the 2 legs of a right triangle, so I would do 3 squared plus 5 squared equals, I don't know, squared. And I should mention right here, I know that 3 and 5 are 2 of the 3 Pythagorean triples. However, the 5 has to be the longest, like on the hypotenuse, so I can't just assume that this is 4. In fact, I know it won't be because it has to be longer than the other ones. So we'll have 9, 25, and when I add that up, that's 34. And then we would square root. And for these types of problems, I like to get approximate answers because it doesn't make much sense to me to say, well, the distance from the post office to the library is square root 34 feet, or miles, rather. Because, like, what does that mean? So what I would do is just square root that boy and not even worry about simplifying it. So 34 square rooted is 5.8. And this is in miles, so miles. Okay, so another one kind of like this, a 15.6-inch MacBook has a diagonal of 15.6 inches across the screen. So it's kind of measured like a TV is measured diagonally. So, oh my God, see, like we're looking at this window right here, diagonally. If the screen measures 7.8 inches in height, what is the width? So truly, I'm looking at a MacBook screen. That's a rectangle. But the moment I discuss a diagonal, you get something like this, and you're looking at a right triangle. So I know that the diagonal is 15.6 inches. The screen measures 7.8 inches in height. I would assume height is up and down. What is the width? So because I have a right triangle here, I can use the Pythagorean theorem. I know the hypotenuse, so I'm trying to figure out one of the legs. So we'll have like 7.8 squared plus the width squared equals 15.6 squared. And I'm definitely going to use my calculator on this because of all the decimals. I can't even with those. So 7.8 squared is 60.84. 15.6 squared, 243.36. And because I'm trying to solve for W and it's not alone yet, I'm going to subtract that 60.84 from this number I just got here. So minus 60.84. And I get 182.52. And again, like they're already given to me these numbers in decimal form. So when I square root now, I'm just going to continue square rooting and getting a decimal. So square root of that means that the width of the screen is 13.5, oops, squiggly equal sign because it's approximately 13.5 inches. Alrighty, on to the next. A 20-foot ramp is used at the loading dock of a facility. If the base of the ramp is placed 8 feet from the base of the dock, how high is the loading dock? Interestingly enough, there are like rules and regulations about this for like wheelchair access. You have to have the ramp at like certain inclines to make sure that it's safe. So like this is actually really applicable. So if I'm looking at a side view of this, we kind of have the ramp, and like to the top of the ramp is sort of the height. And then from the bottom of the ramp is sort of like the distance from the base of it if I go straight down. So usually you get your right triangle right here. What they tell me is that a 20-foot ramp is used. So like the ramp itself is the diagonal one, like the one going up, so 20 feet. The base of the ramp, so like the bottom of it, is 8 feet from the base of the dock. So here, how high is the loading dock? So since we have our right triangle here, we can use the Pythagorean theorem. And I'm just wondering, is this going to make one of those Pythagorean triples? Because I'm just thinking, like, if I divide this by 4, it gets me that 5. But if I divide that by 4, it gets me a 2. And it was 3, 4, 5. Darn. Now let's just do it. So 20 is my hypotenuse. We'll have 8 squared plus I don't know squared equals 20 squared. And I don't want to divide anything like scale it down because I need to find out exactly how big that is. So we'll have 64 plus x squared equals 400. We'll subtract that 64. So x squared equals 633. Square rooter. I don't know. I don't know that square root, so it's probably going to be a decimal. 18.33. So I'll go 18.3 feet. Approximately, squiggly equal sign. And then last but not least here, a roofer leaned a 16-foot ladder against a house. So like I got a ladder leaning. Here's the house. That's how far the ladder's base is from the house. So we got a ladder, house. The 16-foot ladder means that the 16 goes there. The base of the ladder is 5 feet from the base of the house. How tall is the house? Or how high up on the house is the ladder? So I have a right triangle. We can do our 5 squared plus I don't know squared equals 16 squared. So 25 plus h squared equals, oh my gosh, didn't I do 16 squared somewhere already? I'm sure I did, but I already forgot it. 256, I want to say. Yeah, should have trusted myself. Subtracted 25 both sides so that you're getting h alone. So 2, 3, 1. And I don't know the square root of that, so we're going to ask my handy dandy calculator over here. 15.198, so I guess I'm going to go 15.2. Oh my word, approximately feet. And then last but not least, we just got a whole bunch of fun ones here. So, I mean, these are more the same. I think I'm going to jump down and just do these two down here. So, solve for x, approximate your answer. Well, I can find both of these individually, and then I think I need to add them up. So, like looking at this right triangle right here, I would have 12 squared plus I don't know squared equals 14 squared. So 144 plus x squared equals 196. And then subtract that 144. So x squared equals 52. And then square root her. And here's where I'm going to see what sort of answer they want. And since it did say approximate, I'll just square root it right now and get the decimal. Boop, boop, boop. I feel like it's going to be 7-ish. Yes, 7.2. Now that's not all of x, that's just this part. So now I got to go do it again with the 29 and 12, and 29 is your hypotenuse, so we'll have 12 squared. Oh my goodness, I'm getting ahead of myself. Plus I don't know squared equals 29 squared. And so 144 plus x squared equals big number, 29 times 29. 841. Subtract the 144. And then we're already in decimal land, so when I square root the 697, I'm going to just stick with that decimal. Oop, approximated, wiggly. 26.4. Now that's the other part of it. And so to get the whole thing, we'll want to add them up. And this is even a worse approximated answer because I already chopped a huge decimal off and then I did it again. So this is a really poorly estimated thing. But I think we're going to have 33.6 units. And then we'll do this one too because this one looks kind of funky. So if I'm trying to solve for A and for B, like this is the first right triangle that stands out to me. And I don't know two of those things. Like if I want to use the Pythagorean theorem, I need to know two things and I can solve for one thing. Here I know one thing and I'm trying to solve for two things. I can't do that. But I do have this right triangle over here as well. So I think that's the one I need to start with because I know two sides and I don't know a third. So as long as I know two measures, I can find the third, which I can do on this triangle here. And b and 16 are my legs. So we'll do like b squared plus 16 squared equals 25 squared. So 16 squared was that 256. 25 squared is 625. We'll subtract the 256. Oh man, we're going to approximate again, probably, aren't we? So 625 minus 256 is 369, and then square root it. And the reason we say that is because that sucks for finding our next answer. So B is approximately 19.2 when I square root that. And I say that because now when I have to put this here and use it to find my next answer, that's going to give me an even worse answer for A because I already chopped a huge decimal off. Although, so we're going to do like A squared plus B squared equals 22 squared. I actually already know B squared because it was right here, 396. So truly, I don't need to use the nasty decimal. And like when I resquare it anyways, it should give me back to that 369. So that's not too terrible. And then 22 squared, I feel like I know that, but 44. And then we'll subtract so that we can solve for A. Minus 115. And then we'll square root it. And again, we're going to approximate again. So 10.7. All right, hopefully that helps, guys. Lots of Pythagorean theorem.